This video is going to base on how to use remainder theorem, right? So that is exactly what this video is going to be based on. So if you have any question, make sure that you stay to the end of the video and see how best you can apply the remainder theorem. But before we proceed, assuming you have an amount of, let's say you have a $15, 15, right? So $15 in your pocket, and then you give out an amount of, let's say maybe $12, right? So maybe you give this one to someone, or maybe you purchase of any item. So the remainder here, the remainder meaning that what remains here is going to be what, just $3, right? So this is what remains. So the key word here is that how were you able to identify that you are left with what, just an amount of $3, right? So maybe with a brain, or maybe with the help of a calculator, that tells you that if you take away this $12 out of the 15, you are going to left with a $3. So you are going to left the remainder or the balance of a $3. So assuming there's a machine, right? So there's a machine that helps us to determine the remainder. So what I'm saying here is that, let's say your brain is in between, right? So this is your brain. Your brain tells you that if you take away this thing, you are going to left with $3. So what will happen in a polynomial, or to redirect that idea into a polynomial function? So what we are going to say is that this will be your brain, right? So let's say the polynomial function here can be your brain. Right? By the way, don't let this thing confuse you, right? So you have bracket p minus 1 multiplied by the x exponent. Everything here can just be a number, right? So this thing can just be, let's say, 3x exponent 3, right? So which you find the values of the p in just a few seconds, right? So let's say this is your brain, right? So this is the brain. The polynomial function is brain. Your brain here tells you that if I plug in these values here, these values of the x, right? So you have to solve this in just a few seconds. If you are plugging these values into this machine, which is a polynomial function, I'm going to be left with the remainder of 4, 0, and a 5 respectively. All right. So let's have a look at a pure question. So according to the question, we are giving this thing to be the polynomial function, right? So this is what we are dealing with, and then this polynomial function is being divided by what, the x minus 1, x plus 1, as well as x plus 2, and then the leaves a remainder of 4, 0, and the 5 respectively, right? So let's say this one leaves a remainder of 4, this one leaves a remainder of 0, and then this one finally leaves a remainder of 5, right? So what it means here is that, once again, your first step here is to determine this value. So what are we plugging inside the function before we have a remainder of 4, right? So this one goes for this, so meaning that you have to solve this one, which is the x of x minus 1 we equal to 0. This implies that our x equal to 1. So this is what we are plugging inside the what, the polynomial function, for us to determine the remainder, right? So we are going to plug this in. That should be our first step. So x is equal to 1 is exactly what we are giving out. So we give out x is equal to 1. So this is our brain, right? So this brain is going to help us to determine the values that will remain after we give out this one, just $1, right? So you have to plug this one inside of this machinery, right? So this is your brain, and then it leaves a remainder of 4. So let's have a look at that. So here you meaning that f of 1 means that we are putting 1 inside of our function. So whatever you have the x to be equal to 1, or maybe you are going to replace the values of the x equal to 1 in this equation. So here is going to be, of course, p minus 1, right? So x exponent 3. So our x here tends to be 1. So meaning that 1 exponent 3, and then plus px, that which is 1 s squared, plus q 1 here, and then plus r. Is that okay? So what happens? What happens here is that once we plug this thing inside of the brain, the polynomial function, in this case, we are going to be left with the remainder of 4, right? So this one goes for this. Is that okay? So remainder of 4. So meaning that here will be equal to what? Equal to 4. I get to the point. Also, the remainder theory says that once you plug the value this one into the polynomial function, the answer that you are going to get is what remains, right? This is different from the factor theory, not to confuse. If you want to learn about how factor theory, I have a video on that. Maybe you may check the playlist for more. Okay, so quickly you have to solve for this thing, right? So have this thing in a simple form. Okay, after simplify, this is what I had, right? So I had this thing. So we have P here, you have to group everything into one thing, right? So here you are going to have two of the P, so 2P. This is what I had at the end, right? Remember there's a 1 here, so add 1 to both sides of the equation. So here tends to be 5. So I have a 2P plus what? Q plus R equal to 5. So we can name this one equation 1, right? So that is very, very simple in the first step. So the idea of the remainder theory is that you solve for these values here, right? So you solve for the value being divided by and plug that answer into the polynomial function and then solve it nicely. So the remainder here is exactly what remains after plugging this one into the function. So you have to do the same thing for the rest of these two people. So here we are going to solve for the x plus 1 equal to 0, meaning that you have our x to be negative 1. So we are taking this negative 1 into the function, and then as well as what this is x plus 2 equal to 0, meaning that our x is equal to negative 2, and then you plug this negative 2 into the function and see the equation that we are going. So here are all the rest of the two equations after plugging in these values respectively. So here are the three strong equations that I had after plugging in the values respectively. So this is the first one, and then this is the second one, and then as well as this is the third one. So if you have any question on this, make sure that you comment in the comment section below. Is that okay? Okay, so perfect. Now it's your duty to know how to solve these three equations respectively, right? So solving this one, nobody cares about the method that you are going to use to solve these three equations. So maybe give me in the comment section the method that you are using to solve these three equations, right? So maybe someone can go for maybe equation 1 minus equation 2, uh, whichever way you want to solve it. All that matters is that you are arriving at the correct answer, right? So that is the most important thing. So by here I can go by saying that this equation 1 minus equation, so that will help me to eliminate the q here, right? Or maybe add these two, right? So maybe equation 1 plus or equation 2, whichever method that you want to use. So make sure that you arrive at the same answer by finding the values of the p, q, and the r. Okay, so here I'm going to subtract equation 2 from equation 1, right? So equation 1 minus equation 2. So I have what I'm going to have. Maybe this is just a straightforward. So a p doesn't have a partner in the second equation. So we are going to have 2p, right? So meaning that 2p minus 0 gives me a 2p. This q minus negative q here, right? So q minus that's one will also give me a positive a 2q, right? So the r minus the r vanish, right? So that tends to be a 0. So the most important thing, you have to make sure that if you do your operation, you are eliminating one of the variable. That is the most important thing. So here 5 minus this one will give me a positive 6. Is that okay? So this will be my first part. So here I can name this thing equation 4. Is that okay? So since I have equation 1, equation 2, everything is step by step. So just move according to the steps. So now we are glad to eliminate one of the variable from this equation. Now you have to proceed with the equation 3 and then find a ways and means to eliminate one of the variable out of this equation. So whichever method you want to use, that is your own case. So for the second part, I'm subtracting equation 3 from equation 2, right? So equation 2 minus equation 3 gives me 4p plus q, everything equal to 2. So here I'm having two simple equations. So yeah, we managed to move from the 3 variables and then to 2 variables. Is that okay? So this one gives me the idea of a simultaneous equation. So you must know how to solve this simultaneous equation. Once again, if you are gaining values from this video, make sure that you subscribe to our channel, give us a thumbs up, and then share the videos. That helps the channel very, very important to grow. Okay, now let's proceed. The idea here is that solving this simultaneous equation, nobody cares. You are not restricted to use either by elimination or maybe by what, a substitution, right? So whichever method you want to use, that is your own case once again, right? So here, what we are interested in is you solving this two equations. So in solving these equations, we are going to have the values of the p to be equal to. So after solving these equations, this is what I had. So I had what p to be equal to -1 on 3, and then q to be what 10 on 3, right? So these are the two equations that I solved to have the values of the p and the q. So how do you get the values of the r? So you just pick these values, right? So you pick the value of the p and then the value of the q, and then plug that into one of the equation that contains all the three variables, right? It can either be equation 1 here or maybe equation 2, right? And then solve for the r at the end. Okay, so after solving that, I had r to be 7 on what, on 3. If you're having different answer, make sure that you give us the answer in the comment section, right? Okay, so these are the strong values that we have. So the second part of the question is up next. We are giving this to be the polynomial function, right? So the values of the p, q, and r must be replaced by the numbers that we had, right? So here we had a p to be -1 on 3, and then -1 as it is, and then multiplied by the x exponent 3, and then here we had still the p is here, right? So p, which is the negative 1 on 3, and the x squared, and then we had a q to be 10 on 3, and then finally we had the r to be 7 on 3, right? So this is what we are having. So now the only problem here is that you just have to rearrange and simplify everything. So this is the fraction. So this one is going to give us a -4 on 3, so x exponent 3, and then here also tends to be negative, so 1 on 3 x square plus 10 on 3x, and then plus 7 on on 3, right? So this is the polynomial that we are having. Now the second part, it says that you should find the factors, right? So you should find the factors of f of s. That is another term you must understand. If you say that or how do you find the factors, I have a complete video on how to find the factors of a polynomial. Of course, these are the zeros of the polynomial. So what it means here is that anything that I plug, let's see how to do that. Now, the idea of a factor of a polynomial is that if you say someone is a factor of a polynomial function, what it means here is that when I plug that value inside this polynomial function, of course, this is what you are going to use, right? So when I plug the value of the x into this one, everything must be equal to what? Equal to 0, right? It must be equal to 0. If you are not equal to 0, then it means that you are not a factor. So the value of the x that I will put inside this polynomial function, after simplifying everything, I must get the answer to be equal to 0. What is when we say that we are a factor? This is far different from the remainder theorem. The remainder is what remains here, but strictly for the factors of theorem here is that the idea of a factor theorem is that when I plug the value of the x into everything here, I must have the answer to be 0. Now, according to our question, we are given three things to be maybe our divisor, right? So we had the x -1, and then the x plus 1, and then s plus 2 dividing the polynomial function, right? So the only one that gives us 0 is the middle one, which is the s plus 1. So what this thing is telling me here is that this is a factor, right? So this is a straightforward a factor. This is a factor. Is that okay? So that thing is a factor. Why is it a factor? It is a factor because when I plug the value of the x, which is -1, into this thing here, the answer that I'm going to get is equal to 0. That is what we are having, and that is what guarantees us to see that only this one is a factor of this polynomial. So why is it that this x -1 and then x plus 2 are not factor? I need your answer in the comment section below, right? So only this one is a factor of this polynomial. Now for you to determine the rest of the factors of this polynomial here, so we are going to use this one to divide the polynomial function. Continue from this point here, that this is a very nice polynomial that we are having, right? So with this polynomial is going to be divided by the factor here. This is one factor. Of course, you need one factor to be the one that is going to divide the polynomial function. Is that okay? So if you know how to divide this, I have a complete video. I guess you should try and watch that if you don't know how to do a polynomial division. So here I'm not going to do that in this video. So I have a complete video on that. But the key here is that you deal with the x values, right? So the x values here, this x will go into this one, x squared. So the coefficient remains as it is in this case, right? So here we are going to have a negative 4 on 3x or s squared. We are going to have the s squared. So this one multiplied by this will give us a negative 4 on 3x exponent 3, right? So and then this one multiplied by this one. That is how I have a complete this. So I guess you should try and guess. But the answer, let me see your answer in the comment section. I've already given you the first term here. So try and complete this thing and give me the answer in the comment section below.